Recording started. So, today we're going to talk about threads and multi-threading in general, asynchronous programming rather, right? Because this is like the most famous way of doing things in C# right now, depending again on your application, what kind of application you are doing. But let's say 99% of the applications, if you are doing a web development, so you are going over an API, grabbing some data from the internet or from a server and displaying it to the user, like give me the list of all items in a shop, for example. You will mostly do asynchronous calls. So you're mostly going to do asynchronous programming. There are a couple of things which has to be mentioned here. There is a asynchrony. There's the multi-threading bit in it, and there is the parallelism, right? So what is the difference between running in a concurrent manner and a parallel manner, right? So if we have a CPU die like this, and now a CPU, I'm going to refer to a CPU as a single core CPU, which is like, it was like this until probably the early 2000s, where we had just a single core, you had a program counter, you had your registers, depending on how many registers you have per CPU, depending on the architecture. Are you on an AMD or an Intel? So we have here R1, R2, R3, right? And then you have your program counter. And what it does is that you are actually having your code is being converted to assembly. And I'm not going to type assembly here, to be honest, but let's say that you have just a bunch of lines of code. So there's line 1, line 2, line 3, line 4, and so on and so forth. And what happens is that your CPU just goes in and just executes each one by one, right, in a sequential manner. And this is what, in an essence, essentially, like, it goes in that way, just goes one by one and executes the data. And then you have your caches, and then you have your registries where your variables and your data are actually being saved, right? So if you are adding two numbers, so a number will be on one register, the second number will be on another register, and then when you add them together, depending on how you write your program, you might save them into a third register or save them into either one or two. It depends on how you just simply write the program. Your assembly code, rather, right? Now, the problem here is that if you haven't noticed yet, you have your CPU just does only one thing and only one thing at a time. And it cannot do anything else. As long as a certain program is still executing, right? Now, this was actually true, for example, in terminal applications like console applications, where back in the day before the UI was there, you could do multitasking on the in a console application, right? But you haven't seen, like, you can do that in Unix and Linux. You could have seen that as well, right? You don't have GUI and anything, but you have like multitasking system, a fully capable multitasking system. But the problem still there is, how can you actually execute two programs at the same time right now, isn't it? This is an issue here, because your CPU has a single program counter and can only run a certain instructions per time. It cannot have, for example, like another. So if this is one process, or if this is one program, you cannot go on another program and tell the CPU, hey, run this as well, right? So you cannot say, here are other instructions, please run these two as well at the same time on a single core, right? So you cannot do that. So what you usually do, you actually start to saying, okay, you go to sleep a bit, and I will actually grab this one, right? You run a couple of those, and then this thing is already done partially, yeah? Hello? Zaim?
Tu sam ima neki problema što vam radim. Hvala, izvinjavam se.
Aha, ništa. Do not forget to mute yourself. Yeah, okay. Okay. You can actually hear me and see the screen, right? There are no issues, right? Until now? People?
Yes, everything's fine.
Okay,
There's
okay,
no
good.
issues.
All right, thanks. So it says this guy to go to sleep a bit, and then it actually goes and execute this guy a bit, right? And then it simply says, okay, you sleep a bit, and then it goes to this guy and then continues. And this is what we call a cooperative multitasking. This was what, 3.11, I think? Windows 3.11, Windows 95, you could see that as well, right? Old Unix systems. So this is how you actually would do multitasking like this. Now, let us actually go a little bit deeper. Okay, so I'm actually mentioning this for a good reason, by the way. That means that you have a one core CPU and your application is running two processes or two processes at the same. No, I wouldn't say at the same time. It seems to be at the same time. So if you look at the timeline, so if this is a timeline going from top to bottom, so let's say this is going to be process 1, and then it stops it, and then it goes to process 2, executes it for a bit, and then it stops it, and then goes for process 1 again, and so on and so forth. Okay, so it just simply goes like falls through until one of them dies, and it just simply goes away, or finishes and goes away, and then one of them just stays. Okay, so let's talk about this a little bit more in depth. So what happens usually is that you actually enter you create usually a task, right? You create a process, or you create just a task, right? You're asking the CPU, hey, here's well, can I actually type here like this? Yep, I can. So this is a task created. So created task. Okay. It goes into some states. It goes into actually a couple of states. One, it will actually, like, once the task is created, it has to run, right? So the operating system grabs the task and says, okay, what should I do with this? So immediately when it like looks at it and it says, okay, I'm gonna actually put you in the running state if there is nobody in there, right? Now the question boils down to is, okay, what happens if that thing stops working? Okay, now here's the interesting part. If you notice from the previous graph, which I've actually erased, if you have noticed, you can see that, again, the only one process can work, right? So you might ask, okay, what about the operating system? Isn't it? Because the operating system is also a program that needs to execute on the CPU. Back in Windows NT, not Windows NT, Windows 3.11, I think 95 as well, the old Unix, old Apple Mac OS operating systems. I think it wasn't called Mac OS, probably it was something else, I can't remember anymore. Back then, the software which the programmer writes has to hand over the control to the operating system every now and then. So the operating system can know, okay, do I have a task that needs to be, injected or not? All right, or do I have a task that needs to be like, like somebody created another task and needs to run or not, right? So the program usually had this full control over like what's happening on the CPU, right? And then when it takes the full ownership almost of the PC, and it will not let go unless they say, okay, the operating system you can have the control over, right? But we're going to talk about this a little bit later. But in any case, so it comes into a running state and it will stay there until it actually stalls or it is done. Or it might actually take some time and it says, okay, I don't need to be in the running state because I'm waiting for some data to arrive. Maybe I'm reading from a disk, or maybe I am downloading something from the internet or whatever, right? So the CPU is basically does nothing because you are just simply waiting for data to come, right? So here, the task will go to another state. Well, let me put it right there. Right here. And that state is called, well, what we call it? Like what? Blocked? So let's say it's blocked, right? Then once it is actually done, right? It might actually happen that you get another task created already and jumping right here, while this like first task is already here, right? So once it gets actually unblocked, it cannot go back because it is actually somebody is still running on the CPU. So what we end up doing is we add up in the queue. The task goes to another state, which is called runnable. Here, runnable. Okay. And now, once you are done, once this task, for example, whatever it was here, it might actually go to a blocked state, or maybe it's actually done. It can go somewhere else, which we're going to represent in a minute. Right now, whatever was in a runnable, right now it can run back again because it was done with the running bit. Okay. Now, obviously, once you are once the program has finished running, it can actually go to terminating state. Right here. So here. So right there. And let me erase this thing. Erase that thing. Put this thing here. All terminating or terminated state. Okay. So let's see. So this goes here. It goes from blocked to runnable. It goes from runnable to this guy. Whoops. Easy. Go. It goes to here. Okay. And this is what's happening. Now here's the interesting part. When you are in the running state, so let's say, let me change the color here. So let's say you have created a task called T1, task 1, and T1, nobody is actually using the CPU, so T1 comes here, right? So let me try to make this a little bit farther. So T1 comes here. T1 actually does some work, and then waits on the hard drive. It's loading a 1 GB file. It will actually go from running state, because you are waiting for the thing, and do the block state, right? The program hands over the control to the operating system, say, hey, I'm gonna do some work, a long work. You can actually do something else. And then somebody else comes in and he creates a T2. So T2 comes into the running state, right? By the time T2 is actually running, T1 already have loaded the stuff from the hard drive. Now T2 is actually still running, so it will actually go here. It will stay there, so T1 will go into a runnable. Tells the operating system, signaling, say, hey, I'm actually waiting to be run. Now T2 has actually been in the still in the running state. There is a good question actually, so which comes to some people's mind and said, okay, but Mohammed, T1 was existed in the CPU at a certain point in time. So what happened with the registry values? What happened with the RAM state? What happened to the state of the program itself? Like, I actually had a program counter. which says if you have a program like this, and it says the program counter was stopping here. Now, when I put it in a block state, T2 comes in, all this data should be gone because the CPU can only look at one thing at a time. And the answer to that is we actually save the state into the RAM. So we take a copy of all the registers, the state of the program counter position, everything, and then we save it into the RAM. We just hold it somewhere. And then the T2 comes in, wipes out everything, and then just, oh, well, I wouldn't say wipes out everything, to be honest, but let's say it just comes in and replaces stuff. This replacement is what we call context switching, and you will hear it a lot when you are working with multi-threading optimization and optimizing software runtime. You might actually end up with a very slow multi-threaded application just because of you have so much context switching, because your CPU saves the stuff to the RAM and then picks up another thread of your program and then does something else and then saves the stuff to the RAM and then swipe it back and insert back things into the CPU. This takes actually time, like switching back and forth between many threads. And this context switching might actually be the Achilles heel to your program. So yeah, now this is actually, I just wanted to mention this keyword because this is actually very important to know. You will actually encounter this probably in the future. So the question here comes here is you don't like the idea, obviously, of tasks taking over the stuff from the operating system, and yet you have to hand it over to the task has to hand over the work to the operating system. So what you usually do is in the this is what we call a cooperative multitasking. Then you have preemptive multitasking, where the operating system actually starting from Windows NT and onwards and the new Unix or Linux and the new operating systems right now, like the modern versions of it, they say, okay, I will take over control every 200 milliseconds or every 300 milliseconds or whatever X time it takes. And what will happen is it will actually do some sort of a round robin kind of work. So for example, task 1, task 2, task 3, task 4, task 5. And when I say task, I'm talking about, sorry, it should be saying processes rather. So it will go here and says, okay, this will work for 200 milliseconds. And then once it's actually like 200 milliseconds pass, it will put it on the blocked state. And then it will go here, it says 200 milliseconds, 200 milliseconds, 200 milliseconds, 200 milliseconds, done. And then it will just simply go back, hand over control to this guy, and then just, goes over each one of them. Similar to round robin. Or actually, this is kind of actually similar to round robin kind of story where you rotating the tasks in a queue and you are doing it really fast that your computer actually you don't feel it, right? And this is how actually things work. You get, for example, a 3 gigahertz CPU or 2 gigahertz CPU back in the day. The faster your CPU is, the faster it switches between these tasks, and you feel your PC is actually much faster until we hit the limit. So right now we need to use multiple cores, right? And the multiple cores, right now the multi-core thing is actually quite interesting because you don't actually anymore execute stuff on one CPU. You have 2, 3, 4, up to, I think right now the servers have 128 cores, 200. I don't know if there's 256 core CPU right now, but the server grade, like a server on Microsoft, for example, Azure and stuff like that, they have like 128 core per CPU. And you could run, what means by core right now is that you have several CPUs. So you have like multiple of these running at the same time. So right now you can have multiple program counters running at the same time. So if this is a program counter, there's another program counter running another process at the same time as the other core, right? And this is what we call task parallelism. Right now, these things are running in parallel, okay? So I just wanted to to like give you the difference between something is running in parallel and something running like in, let's say, asynchronous. Okay. Running like so asynchrony simulates, gives you this feeling of things running at the same time, but they don't. But in parallel, they actually do physically run like at the same time. Does this make any sense? People?
Yes, yes.
Okay. So again, this is like a refresher. If you have come from a like once like this is a refresher from operating system course. I'm just refreshing your memory because of when you look at things right now when I'm programming, most of your programs are actually a single core programs, not a multi-core programs, just to be clear here. And even if you're going to be working in production or something like that, most of your applications are going to be running on the cloud, and usually like 80, let's say 80% of the time, your service or your query or whatever API call you're going to do, usually it runs on a single core right now, and that's why people are using asynchronous programming a lot. It's actually much easier. Like not I would say much easier, but well, yeah, it's actually easier in a certain sense. But in any case, multi-core programming requires a different kind of problems that you need to solve, and probably we're going to touch upon that in computer graphics, because GPUs, for example, are massive parallel bunch of CPUs, right? You have like I don't know how many cores in a GPU right now, but there are like what, hundreds of cores that you need to, for example, run things on it, because you can run a task in parallel. But yeah, this is another topic for another day. So let's actually get now since you have some sort of a sense of what how a CPU works with a task in general, or works with a process, I would say. Now let's talk about threads. Let's see. Now threads are actually fairly simple, by the way. I can actually do this probably. Let me create a new class, and I will have this called intro to working with threads. Okay. Maybe I will rename this even to like 01 dash. I'm just naming the file, so it can be like chronological order. I'm gonna make it static because I would like to call it from the program.cs without having to instantiate objects and stuff. So what can I do? Right, that's the question. If I have a tool, like let's talk about our screwdrivers, let's say, right? So var current thread equals to, oh wow, okay, there you go. It's beautiful. It detects it immediately. So, whoop, not this one. Current thread dot name, and here the name is actually empty, by the way. There's no name for a current thread. So if you actually get that thing, so if you try to get that, display this. So let me actually like console.writeline. Come on. Dot name. And if I actually run this, oh, what did I do? Intro to working with threads dot. There we go. So if I hit F5 right now, and if I bring this here, as you can see here, it's nothing. Nothing is printed out, right? So what I could do is actually actually modify this. So current thread.name equals to hello world of threads. Now, this is usually used for debugging purposes. You shouldn't rely on naming threads and accessing them by names, by the way, just to be clear here, okay? So if I run this right now, you can see that it actually prints out hello world of threads. Okay, let's move forward. So what else I can actually get? What kind of other information do I get from a thread? So console.writeLine. Oh man. And right here, I can actually get the thread ID. So, so I can put something like this and can say current thread ID, and then it's going to be current thread dot manage thread ID. Okay, and then I hit F5. The current thread ID is equal to 1. And by the way, you usually don't set this because this is a read only. You see, it's get. So it's actually good that you, but I mean, if you would like to know that you are, it's good for debugging purposes, but you cannot actually set this, right? Or you cannot rely on it to say, what thread are you? Okay, you shouldn't actually do that. The also interesting things which you can do with this one as well is that if you are having multicultural kind of application, you can actually also ask current thread culture. And right here, it depends on, right now, for example, my PC has a different culture here. So if I actually put this, so it says current culture is ENUS, probably yours is going to be what, BA, and then BIH, I think, depending on how did you set up your computer. You can ask questions like, is that thread alive or dead? So is current thread is alive, for example, are you alive? So current thread dot is alive, which is a true false. Let's see, what else can we ask? For example, are you, is background thread? And then we can have here current thread dot is background thread, which you can set, by the way. There's a foreground and a background thread, which we're going to talk about in a minute. But let's see. So this guy is a foreground thread, not a background thread. This is actually alive. So because it's the current thread, it has to be alive while it's running. Obviously, once it's done, it's dead, right? Let's see, what else can we ask? Questions that are useful. Current thread state, and then you can say, what are your thread state? There you go. And if we run this right now, for example, while the program was running, it was saying running, right? Once the program is dead, it will not be, it will be something else. I think it's a read only. Yep, it's a read only. You cannot set that. So console, WriteLine, current thread. What else can we say? What is the apartment state? And this is actually quite interesting because you will know about this once we get to Windows Forms. Well, I don't know if you have actually noticed it, but you will see in a minute. Get apartment state. This is mostly related to COM and how Windows work. So right now, in this current context, it's called the multi-apartment state, or multiple apartment state, multi-threading apartment, rather. Multi-threading apartment. And multi-threading apartment is, how about I actually describe this when we get to Windows Forms, because it's actually going to be much easier. Because it's mostly related to really how Windows work. Current thread policy. Priority, sorry, priority, what did I, why did I hold this? Priority. Here's going to be current main thread priority. And right now you can actually also set that. So you can say it is high priority, it's a normal priority, and so on and so forth. And right here it's normal. Okay. So these are the questions which you can ask. So I can actually say current thread dot priority. I can say dot here. Come on, dot. And right now you can say lowest, highest, below normal, above normal, and so on and so forth. Okay. So you can actually like say how much priority this thread should have. So you can signal the operating system, hey, give it all the resources possible. So this thing can run as fast as possible, right? So these are the interesting thread informations that you can ask or modify. Okay. Now, since we know about the thread information, let's talk about starting one. So I can say public static void, void, and running threads for now. And right now here I'm gonna have var. Well, actually, the simplest thing you could do is something like this. So if you actually, you can say new thread, and a thread takes in couple of constructor, like it has a couple of them here. One of them is, so we have the thread start parameterized thread. I think it's called, parameterized thread. I mean, anyway, it takes a delegate because I need to see if I can actually grab this thing. So parameterized thread, you see, it's actually, this is a void delegate that it takes an object, right? It takes an object as a parameter. There is also, I think, what was the other one? A thread, like a delegate, is a function pointer, as you already know. There is a thread start. So thread start is a delegate, is a void delegate, which doesn't take anything. So if I actually say Alt F12, this is how it looks like. So it's a function pointer which points to a function. It has this name. This is the name of the function pointer. It points to a function that doesn't take any parameters and it doesn't return anything, right? So that's why I could do this. Right? It is the same thing as, like, I can here have a, horizontal right line. Hello from a thread, right? It is the same thing as me saying that I have a public static void, because I'm referring to this from a static function. My function, or my method rather, and I'm saying this. It is exactly the same thing as I'm saying this, but it's much easier that I write it all in one line. Okay, so if I run this right now, hello world of threads. See, it's right there. Okay, so I'm not gonna do it that way, to be honest. I'm just gonna make it like, I'm gonna try to make it easier for myself. So I'm just gonna make this like so. And you do the thing. Now let's actually simulate some task here. So I can actually say thread started. I'm gonna call this thread 1 started. And here I'm gonna have, actually this is weird. It shouldn't actually run, but hey. Oh, sorry, actually it didn't run. I forgot to reference this. There we go. Sorry about that. Apologies. Why nobody said anything? I just didn't notice. Let me actually like comment this out. And let me, I mean, honestly, it's the same. I don't want to write this again, but, and this is thread 1 ended. And I'm just naming it 1 because I'm just saying it is number 1. Nobody knows if it's 1 or 10. Thread.sleep. And right here, I'm just going to make this thing stop for a second. So it takes in milliseconds. Okay, milliseconds stay in my timeout. So if I actually run this, okay, how about this? Console.readline. So it doesn't actually start until I actually press a button. So when I bring it here, it hasn't started yet. So if I hit enter, nothing happens, right? And nothing happens because I didn't start it yet. So I can say .start. And now, if I hit enter, started, it took a second, and then ended. Okay? So that's, and then I actually instantiated a complete new thread. Now, what I could do also, I could actually do this. Var t equals to that, so t1. Now, obviously, I cannot do this anymore. However, I can say t1.start. You can do that as well. Okay, but I just did it all in one line. Now, what you can do this. Let me start like 4 of them. So 2, and this number 2, 3, 4, and 4. Now, if you actually look at this, you will notice that you might think that this will run in sequence, but they won't, or they shouldn't, because they will all run in parallel. So you see, so 1, 2, 3, 4, and then the ended, so 3 ended first, 2 ended second, and then 1 ended, and then 4 ended, right? So it seems to you like they all started because the program just simply falls through and just simply like things will take actually their time, right? So this started, but it doesn't necessarily mean that they actually started in order. They started differently. And there's no guarantee, absolutely no guarantee, that they will always be ended up in the same order. So this is the rule number 1. Please remember this. When you are working with multi-threading, do not think of order yet. Okay? There's right now pure threads, nothing more. Now the question boils down to here is like, okay, how can I debug this? Right? This is a very good question. So if I actually hit here F9 and I hit F5, and there's a very important window you need to know about, which is, I think, under debug window, you have tasks, which is needed. Parallel stacks, I think this is for you to see the parallel stuff. Here are the threads. Okay, so if I hit this, you will see all the threads that are running in your application at the time being. So if I hit enter, there you go. Now, please understand that I'm well aware that what you are looking at is multiple threads right now are running. So there's only one thread created, but there are many of them. This is, I think this is new with .NET Framework. I think it's lately introduced, but I cannot remember really which .NET Framework has introduced this. They utilize multi-threading in order to make sure that they load the DLLs of using system and other stuff. So these stuff gets loaded really fast. So they run it on multiple threads at the same time, right? And that's why you have this is running. Now, the worker thread is the one which is Actually, I think it's has been created here. But if we look at this, this is the current thread which I'm in, and it says that this is the one which is running. So what I could do actually is try to see if I can, just for demo purposes, because it's important that you have a feeling for this. T dot current what manage thread ID. So can I do that actually? T might be null here. Nope, it cannot be null here, but okay. Or how T1 can be null? Maybe not. Right. I'm actually doing this all at the same time. Sorry. Yeah, of course. Now I get it. Okay. Yeah, actually I like the shorthand of this thing, to be honest. Nah, I'm gonna keep it. Hang on. I think there is one way of doing this better, probably. Mm. Hang on. Yeah, I can actually do that better. T1.name equals to, and I can actually name this. So thread 1. There we go. I can actually do this and thread 2. And we can do this. 3. And this is going to be 3. Just before it's starting at 4. And this is 4. So 3, 3, 2, 1. All right, perfect. So let's hit the 5. And let's get started. Yeah, we have right now more. But there we go. You see, right now all of them are named. Remember that this actually has moved through all of them. So this has executed all of them until here. That's why you see thread 1, 2, and 3, and 4. Do not think that that this ran immediately. Okay, so this is very, very important. And now I'm actually running at thread 2. So thread 2 actually runs first. Now, obviously, because I spent too much time explaining things, if I continue, this is already going to be done. And once things are done, it will immediately like kill the whole process, right? So let me see if I can actually stop this from running before I say so. So run this. So right now we are at the current thread. And it says it's ended. But right now these guys are pretty much dead, I think. So if I hit enter right now, this is actually going to be done. So, all right. So I just wanted to demo for you that all these guys run at the same time in parallel, right? Or let's say concurrently, because in parallel means that they're going to be running on multiple CPUs, but this is a single core program. Okay, so this is one thing here. Now, if you have noticed one thing, I just wanted to also mention here that when I actually run this, the program actually runs and finishes like, let me actually move this. So the program doesn't actually end until all of the threads have ended, if you haven't noticed yet, right? And this is by design, because if I actually say this, if this became a background thread, oh damn, I actually forgot myself. 4, 3, 2, and 1. Okay, currently we're running foreground threads. If I run this right now, you see it ended, meaning that we have run a non-blocking thread, meaning that when the threads are running, they are a background thread, not a foreground thread. meaning that they don't have the priority to block the program anymore. So if the program finished, it will kill all the threads at the end without even, whether they finished or not, it doesn't care. It just simply say, hey, just axe those people, just kill those guys, and I don't care. So that's why I just simply instantiated all of them. It's all run, and then once it reached here, the end of the function, jump back, end of the void main, exit, right? So this is what the difference between a background thread and a foreground thread. Okay, a background thread means that you mark the thread as like, if the program finishes, just kill the thing. Do not block the main thread. But if the background thread is set to false, it means that right now that thread is a blocking thread. So you cannot finish the main program unless this guy is already done. So this is very, very important. I think there is a thread.stop, probably t1.stop or end or interrupt. There you go. So you can actually interrupt the thread as far as I remember. But again, this is like away from the scope, outside the scope. Let me see, before I actually would like to give you a break, I would like to also show you something really quick. I would like to finish the threads bit. Public static void. Generate multiple background threads. Can I actually generate many of them? And yes, I can. So for int I equals to 0, and I is less than 10, there we go. I can generate 10 of them, why not? var equals to new thread. Oh, don't you just like this autocomplete? Man, it just lifesaver. Now here and so, and right here I can say let's actually have more fun here. So thread dot current thread dot manage thread ID. This is one way of getting the actual current thread you are running ended. Now the thread ID doesn't necessarily care about what number it is. It's actually assigned by the .NET framework. So I can say t.name equals to, and I'm going to actually name it just in case. So for debugging purposes, thread of I. So I can actually see it in the debugger. And then t to start. There we go. And then I will hit enter. Of course, I have to call this thing because, you know, you should call your functions. Dot start. So it actually started like 13, 10, 11, 19, and all of them ended. So right now, for example, this is a foreground thread. Okay. And by the way, this is the thread IDs. This is not the counter, by the way. So if I actually say, oh yeah, I cannot say it here. But basically speaking, if I actually go and hit maybe F9 here and F5 and start this, so far, this is the main thread. So we started one, so thread ID, so thread 0 of 10. So there's the managed thread ID, okay? So if I say continue, and it should start another one, right? And continue. I'm trying to see if it will actually jump. Oh yeah, of course, because I didn't put an F9 here to know which is actually blocked. But in any case, I just named the thread so you can see them in the debugger. So this is actually a foreground thread. If I say it, I can actually say background thread. So to match this, and if I run this, 10 threads just gone. because the program has ended. So right now, you know how this actually works. So you can actually create a multiple of them. Now, usually you don't actually create a thread like this. I mean, this was a long time ago before we had these interesting keywords. The task was introduced in, I think, C# 4.0. But before that, when we had to do multi-threading, we really had to do this. We really were like creating threads by hand, which is super expensive, by the way. This is computationally expensive. Void generating multiple threads using thread pool. And this is just for completeness sake, because I would like to complete this part, and there's one more function to have just to show you how things work, and this is it. So here I'm going to have instead of thread, I'm going to have a thread pool. Okay. And I don't need this, obviously. And this is gone as well. And a thread pool actually takes a parameter. I'm gonna just put an X here because it doesn't care really. Let's see. What is it? Right. Sorry about that. I just made a Dot Q user work item. There we go. Now it's much better. So whenever you run your program, there's a more optimized way of working with threads, is that you use something which is called a thread pool. And a thread pool, basically speaking, is you have your dotted framework will prepare for you, let's say 10 threads, for example. And these 10 threads will be there for you to utilize. So you instantiate, let's say, 1,000 of those. Okay? So you have 1,000 threads. You will not run 1,000 threads in parallel. You will just run, let's say, 10. So you can say, okay, the thread pool size is 10. It will just simply grab like the first 10. Once one is done, it will just simply say, hey, that thread is free, reuse it, right? So you have 10 reusable threads, but you will not allocate 1,000. You will have only 10 is allocated. And once one thread is free, it will be just reutilized again. And that's it. Like, it's called pooling in general. So this is called an object, or yeah, so that's why we use thread pools. It's much more efficient to do. Now, obviously, if I run this, right now the thread pools are actually non-blocking, by the way. So again, sorry about that. I forgot. I have to I have to call this thing. So let me just did it, and there we go. Thread pool. So it's a background thing, right? So it started like a bunch of them. So we have like what, 20 something? I don't know. Oh, actually, yeah, it's the managed thread ID. So it started like a bunch of them, but it didn't wait until it finishes. But let's see, can I actually have something like, could it actually wait until here? I don't know. I will see. Because there's a way to make them wait, actually. Yep. I can make them wait like this. So right now it actually started, and some of them actually ended. And once it ends, it actually grabs it again. And you will see, yeah, it's actually 1,000 of them. I should have made it a little bit smaller, but let's say, so ended 16. Is 16 started anywhere else here? Or did I get something from before? I don't know, 2015. Oh man, it's running so fast. Okay, let me actually make this a little bit smaller. Let me make this 20. So let's see. So we should actually be able to see the same thread utilized again. So started. Oh, probably I should have given more. I should have maybe said 50. Oh, okay, 60, fine. Just missed the key. So let's see. It should actually use a thread somewhere. So, yeah, okay, whatever it actually started has ended. Okay, it's 31 started. There you go, you see? 31 ended because it was started somewhere in the top, hopefully. There you go, 31 started. 31 ended somewhere here, then actually started again. That's because the thread pool just, you reuse the same thread. And that's it. This is why thread pools are actually quite efficient. You don't need to allocate more threads. You just simply you have a pre-allocated bunch that you simply reuse. Now, this is one way to block this because, but again, like not all applications will allow you to do this. This is kind of a stupid way of doing this. So there's a way to do this, and it's a little bit complicated. But for the sake of completeness, generating, let me actually do this. Don't go until done. Now, this is going to be a little bit interesting. So first of all, you need to know how many threads you are generating, right? So this is very important. So number of threads to process. So let's say we're going to do 60 as the previous example, okay? Now, there is another thing. There's an interesting object called the manual reset event. Reset event equals to new manual reset event. I'm going to put this to false. Now, there's a very important thing here. The initial state is false. Now, it's using because I need to dispose this once it's done. So I need to free the memory. This has to go away, okay? A little bit advanced. You will not see, probably will see it in, I don't know if you'll see it in production. I mean, you can see it in production in a different context, but not in this. But again, I'm just making this for the sake of completeness. I will not dive deep into this because it's actually out of the scope. But again, I'm just not to show you something and say leave you, how can I fix this issue? Because I don't want to put a read line in there. So I'm going to create a new list of threads, or sorry, list of ints. It's going to be a little bit cryptic, but hey. And then for int I equals 0, I is less than 50, which is, again, the number of threads which I'm going to generate. And right here, I'm just going to say lst.add 50. Or, sorry, apologies. There we go. I'm just putting it to the same line here because I would like to make this short. Int I equals to 0. I is less than, let's say, 50. I plus plus. I don't need this. Okay. And right here, I'm going to do my thread pool stuff. Right there. Now, here's the interesting part. Now I need to actually decrement every time I run this thing. I need to decrement the number of process thing to process because it has been already created. So interlocked, and this is used. It's actually said here, provides atomic operation for variables that are shared by multiple threads. So we're going to talk about this after the break, in one of the examples after the break. If there are multiple processes accessing the same shared resource, you need to make sure that not all of them are accessing it at the same time. You need to make sure that only one accesses it at one time. And this is one of the reasons why we use interlocked. So interlocked.decrement, it has increment, it has exchange, it has a lot of stuff. So .decrement, and then we pass the actual number of threads to process by reference. So we're going to decrement it. So if this thing equals to 0, that means that it's actually that we are done with. We are actually done with the actual generation. Oh, sorry, with the actual threads. Actually, it should be here. Sorry. Reset event.set. So once this thread is done working, please decrement the number of threads to process. That means that I've actually processed the current thread. It's done. Decrement that counter. So, and here, actually, Right. Hang on. Yeah, this has to be changed a little bit. So this is actually going to be new wait callback. Something like this and this. And right here is going to be LST of I. So wait until this guy actually finishes, practically speaking. Okay. And right here, I'm going to say reset event dot wait one. And right here, I'm going to say job completed. So wait one is, oh, sorry, this actually, this is the parameter I meant to be here. Console, that's right line. Job completed. Now wait one will signal that this is actually done. And right now we can actually exit from here. Okay. So if I run this, and I cannot run this unless I call it, obviously. So I'm just gonna the dot here, this, and this, and this, and run. So right now it will actually wait until it's actually done. Now I actually generated 60 threads, did I? So we will wait like what, 60 seconds? And as you can see here, the console write line job done didn't appear yet because it is actually running and keeps running until that thing is actually like done. Or is it? Is it done? Oh, well, did I complicate things that much? Mm. Oh, yeah, I said we have 60 of them here, but I made like 50. So it's still waiting for it until it finishes. All right, so there you go. Yeah, I made 50-50, even though it just says 60 here. So according to this counter, according to this guy, it says, hey, I'm not done yet. There are 10 more to be processed. And there you go. You see job completed, and then it exits. Okay. So this is this as you see here, it's similar to async. But we're gonna talk about that after the break, hopefully. So right now, this is like a quick introduction to working with threads. I just shown you, just to recap, I've shown you how to get some information out of a thread. What happens if you run multiple of them at the same time, even in a for loop? You saw instead of me like writing them down like this, I can generate them in that way. If you uncomment this, you will get a background thread. How to generate them using a thread pool, but they become a background thread. You cannot actually await them. And this is how you can wait for them to be done using a thread pool. Okay. So I will actually give you a break of 10 minutes. So right now it's 3:30. Okay, fine. Let it be 3:35. So for what? 4:45. So there you go. We'll see you after the break in 4:45. Please, if you have any questions, feel free to ask in the chat, and I will be happy to answer them. As for me right now, I think we're gonna see each other in like 10 minutes, so in 4:45. Can you hear me? Hello. Hello.
We can hear you.
Okay. All right, I was starting to dig into my settings and see what happened. Okay. All right, let's actually step this up a notch, just a tiny, little bit. Let's actually try to make something that's actually so if you have noticed so far, there's one more kind of threading. I will just one way of using threads I wanted to show before I actually wrap this bit up. I'm gonna actually like put it in another class, not a new configuration file. Sorry, don't save, delete. Alt-Shift-C right away, so we don't have to waste time. I think this will be called like what? Second phase, intro to working with threads. There we go. It is too long, but who cares? This is all demos. 0 to dash. There we go. So we can have it like organized, and it's public. All right. So let us actually try to make something that takes time. So far, we have actually thread.sleep. There is actually thread.sleep and task.delay, by the way. And both of them, they do the same, like it feels to you that they do the same thing, but they don't. Thread.sleep actually simulates, it can cause a context switch. So if you remember, like switching between the processes and stuff, because it simulates an I/O operations, or I/O operation, like operation, like you are trying to get something from a disk or something like that. Where task.delay, I think it just simulates a CPU timeout or something like that, like some sort of a process that takes a little bit longer time on a CPU, as far as I remember. Hopefully I'm not wrong on this regard, but this is like the main difference between them. I mean, yeah, so, but basically, I mean, they seem to work the same, but they are not the same, okay? So this is very important. Public static void. And let's actually simulate something that takes some time to work. Downloading, for example, a resource, blocking. So right now I'm going to block the main thread because I'm going to actually do something that takes time. So let's see, var thread equals to a new thread. Perfect. Let it be non-blocking for now. Sorry about that, non-blocking. So let's actually take it a little bit easy. Let it be non-blocking. So what you will do is, what will happen is if you actually say console.writeLine, for example, starting the downloads. So right now you are actually downloading the thing, right? And then you can say var downloaded data equals to, yeah, actually we need to create an HTTP client, I think. So var HTTP client equals to new HTTP client, okay? And then you say HTTP client dot get string, and it's async, but we will ignore that for now. And I'm gonna actually download it. Yeah, so there are actually like free APIs on the internet. So I'm just gonna show you one of them. Free APIs that developers can go for. So if I actually go here and hit paste right there, this is an API that once you ping it, it will actually give you like a response that looks like this. It's actually relatively big. Okay. Now, obviously, it has URLs and has some categories. It has some interesting information, like per record, and it's actually yeah. So there are like 1,425 of them. I mean, that API gives you like this list of websites, which tells you the description, the authentication for each one of them, and I don't know, and the link for that thing, right? So it's something that it's free that you can access. So I'm just gonna actually download that thing, like the text which you have seen. I will just simply download it here. So I'm just gonna say done downloading. Okay, and then I'm just gonna say console.writeline result of the download. And then I can say console dot foreground color. I'm gonna make this green because it's easy on the eyes, I think. And then here I'm just gonna have downloaded. Sorry, not without this. Downloaded data.result. Okay, and I have to say .result because this is an asynchronous operation. Okay, it gives you a task.string. That's why it's gonna be blocking. We're gonna go look at tasks later. Console.writeline because right now this is gonna be the heart of your. I'm evolving things. Not console, actually console.foreground color because I need to reset it back. So instead of this, it's going to be white. And then once it's actually created, just simply start it right away. So this is done, and I don't need to create that object actually. Or you know what? I can actually let it keep it. There you go. Thread.start. Because why not? Now I'm gonna copy this, and I am going to X this and go here. Close this. So this was, whoops, this was intro begin. And this is intro end. So right now, you know, this is the beginning and this end. This is going to be like what? Second phase. Begin. Second phase. End. I'm just going to paste my code here. And it's going to be second phase intro. So dot. There we go. And right now, what we should be expecting is the following. So a new thread will be generated. We will download the data. We will block everybody. The thing will wait. Actually, the cursor will start blinking, and it just waits until the whole thing downloads. And once it's done, it will give us the actual result, right? Now, here's the interesting part. So if you look at this, it says start download, done downloading, result of the download, actually done downloading, sorry. So it actually started and it's done. However, you know what? Let me actually try to make it a little bit different. Wait. Let me actually say here, console write line. Write line program finished. So F5 this, hit enter. And if you look at this, okay, so this is the result which we have shown you on the browser. Program finished, so it's done. But the main thread is actually still a foreground thread, okay? So because it's actually a foreground thread, it didn't actually go away. It just simply blocked the main program from finishing until it's actually done. So once it became done, It just simply says it started the download, done downloading, and then once the downloading has done, it actually just simply shown the result. Okay, so this is one way of doing things, by the way. Another way of doing this is that you could actually, I could copy this thing. You could achieve the same effect. There's actually blocking as well. Both of them are actually blocking, not non-blocking. Blocking one. So, hang on. Both of them are blocking. Sorry, I don't know why I called it that way. Blocking one. And this is blocking two. Now, this is blocking one, which is okay. Now, blocking two, there's another way of doing this, is that you could say, so you actually can start the thread. And once it's actually done, you can say thread.join. And what thread.join will do is exactly the same as if you actually have done this. It made the whole thing just go through one step by step. So it doesn't actually it will actually block until it's actually done. So let me call this first. So let me actually run this. You see program finished? So sorry, this is actually I can call this really blocking right now. And this is, we can call it non-blocking actually. So let me actually get that back. So let's say let's do it so. So this is actually blocking. Because it's literally blocked your program from running or finishing until it actually done, right? So this made it in sync, put the whole application in one line. So be careful when you are using, for example, join. So this is very, very important. Okay. Now there's a better way of handling this. Okay. So actually, if you notice that our program, our thinking is actually evolving step by step. So the first step was looking at what kind of stuff we can do with a thread. We right now can do multi-threads running at the same time, even though they are doing essentially absolutely nothing. Right? They are just simply sleeping. But we know that they are doing we are simulating some work, so we can have multiple threads running at the same time. We know that we can actually run them, generate them in another way, like in a for loop. We could in fact put them use a queue, or sorry, a thread pool. Wait for the thread pool to be done. We could do an actual work by downloading stuff with non-blocking way. So for example, the thread will start, it will reach the end of the program, but the program will not end unless this guy ended, because this is a background, this is the foreground task, not a background task. But once actually we would like to make this program run in sequence, that means that what happens if I, for example, say, hey, Mohammed, you run the thing, you output the thing, but I would love to use it, right? What if I would like to use this downloaded data to do some operations on it? Now you need to make sure that this program runs in sequence. So once this is actually done, you say, okay, once this is actually done, then you continue working. And right now we forced somehow a linear way of working with a program. Now, this is not the only way of doing this. There are ways to do callbacks. So for example, say, okay, that thread is done. Please make a callback. Run another function that it actually does some operations. But right now, the code will start to get complicated. And this is why we actually not going to go that route anymore, because it's quite rare that you're going to use threads directly like this. Most of the time, you're going to be using tasks. All right, so Now that this is actually done, let's actually talk about tasks. This is the stuff which you're going to see most in production. I mean, you're going to see threads maybe in production, but I don't know. I don't know. I haven't seen projects using threads like this directly. I mean, since the introduction of tasks, just to be clear here, because these stuff are expensive to do to work with. So I'm going to actually comment this. Let's get into the third phase. Right now we are evolving, right? So first we worked with threads, now we work with tasks. And then once we finish the tasks in console, right now we evolve it into UI. And right now we will see the problems with UIs. And then I will talk to you about the apartment issue, like this guy, where it was. This one. Okay. All right, so third phase end. Okay. Now, example of working with tasks. Let's see. So let me actually run this. So Alt-Shift-C. Alt-Shift-C. There we go. Sick of menus. And here is going to be working with tasks. And working with tasks is a breeze, actually. Once when it was introduced, it was like, yeah, it was a life changer, I think. Public static void example with task. And actually task is super simple. You just simply say task.run, and it will rely on thread pool, by the way. And right now you write your stuff. So I can actually like literally grab, not from here. Let me grab something that takes time. So I'm gonna grab this guy and paste it right here. And this is it, actually. This is it, done. You don't need to create new threads or create anything. So I'll just run this. Now I'm gonna have here, what was it called? Working with tasks. There we go. Now you will notice something quite interesting. If I hit enter, it's actually done. Right? So what now? How can I actually get the result of this? Isn't it? And this is where we actually have to say, or we have to tell, hey, please wait for this thing to finish. And then once it's done, please continue the rest of the program, right? We would like to get this effect of, let's say, this guy. So running. Once it's done, you continue the application, right? So, so for example, something like this. Okay. So let's say you would like to, get this done, and then this guy is done. So we need to use something which is called async. Now, there's a big disclaimer I would like to mention here, and it's super, super important, and a lot of people make a mistake in there. People look at async as something like magical keyword that creates threads. Please understand that async is used along with something which is called await, right? So you have these, Microsoft introduced these two new keywords, but we're going to talk about this in a minute. If you decompile this, if I take a decompiler right now and decompile this method, in fact, let's decompile it now, just to prove a point. I don't know if it will be removed, but let's see. Can I get? Uh-oh. Uh-huh. Oh yeah, right. I removed that thing, but I don't want this to generate. Oh, it will not generate anything actually. But yeah, because there is no async and await, so I can Control Shift B right now. Run this. Give me a minute here. Let me try to find file spy for you, and let me grab this guy. Put it here. Oh, really? I mean, I'm looking at this right now. It says it does not contain a. Why it doesn't contain anything? Why? What happened? It cannot decompile this anymore? Or do I need to update? Nope, I don't need to update thing. It doesn't contain any managed metadata. Oh, what? Since when? Could it be that the .NET framework? Like, no, it's impossible. What about this? Oh, that's weird. So right now, this is actually a console application. Honestly, I didn't notice. So this is a console application. So the project DLL, that's weird. Right now, I opened the DLL, and it actually gave me this. It's kind of weird, but okay, fine. Let's see. So where are we? Working with tasks, and here is something. Do I have to say, let's say this? Uh-huh. There you go. So async is a fancy state machine, okay, that allows you to create something that allows you to do the switch between the main process and delay the current function which you are doing, right? It is not multi-threaded. So async and await by nature is a state machine. If somebody tells you async await is a multi-threaded, it isn't. Okay? It will be multi-threaded once you start utilizing tasks like this. So once you say async, and here you have to say await, it will become multi-threaded. Right now you have multi-threading. It's not only a state machine, it's actually multi-threading right now. Okay? But if you don't have tasks here, if you don't return a task, if you are not awaiting a task or returning a task or any of that stuff, you are not in multi-threading world. You are in just normal synchronous world. Okay, it's just a state machine. It's a fancy coroutine right now. Okay, very, very important. Very important that you understand this. Okay, and I've already proved it. Here you go. There is nothing in there. There is no threads whatsoever created in here. Okay, so yeah, like, super important. Okay, so now this is actually out of the out of the system. Let's actually try to start this thing. So if you would like to wait for this to be done, Microsoft actually have introduced this two keywords, async and await. And if you say await, it has to go with it, async. You cannot do one without the other one, okay? And you're gonna be, if you're gonna be a full stack developer or a C# developer, you're gonna be using async functions and await function all the time. All the time. Okay, so this is like in the exam, you're gonna be doing this. In Erisiyad and Erisvai, we're gonna be doing this. Okay, so right now we evolved into this async and await. Okay, right now I'm making a very terrible mistake. Okay, which is actually a function that returns a void. And everybody is warning about this, but very few talk about why. Okay, so very few talks about the why bit. So I'm gonna tell you why in a minute. But let's see how this will work first. So if I run this, and if I hit enter, did I? Of course, I have to await the thing. Now, of course, if I have to await this thing, it has to be async here. Yeah. Oh, of course, it cannot await void. Yeah, how did I actually resolve it? Yeah, this has to be task. Because oh, sorry about that. Not this one, not yet. Cannot await void, can't it? I cannot await void. How can I force this? How did I force it? How did I force it? You know what? I'm just gonna actually grab this right now. Because awaiting void is actually not gonna happen. So I'm gonna do this. Okay? Because I mean it will not allow me, but I need to simulate this. And of course this has to be async. So I have to mark it there. And this is gonna be await. Okay, and I'm gonna hit run. Program does not contain the main entry point. Yeah, obviously. This has to be tasked. Microsoft, yeah, just to remember here, once Microsoft introduced async, they introduced several signature of main function. One of them is this. There are many signatures of main entry points. So let me run this. And right now it actually runs. Okay. So if I hit enter, there you go. It started downloading. And as you can see here, it actually didn't run until like program finished, run after the whole thing has downloaded, right? So it actually blocked. Result of downloading, it just simply blocked for a while until this whole thing is being dumped. And then once the whole thing being dumped, it just simply said program finished. Okay, so it saved this sequence of things moving, like of the whole flow of the program. And this is actually important if you would like to say, okay, the downloaded data, I would like to operate on it later somehow. So this is one way of doing this. Okay. So now let me actually comment this, because right now this is actually not that very useful, but I just wanted to prove a point here. And we go back and let's actually talk about why this. So this is actually we cannot do this. So this is illegal. Okay, so say cannot await a void when called from main. Don't do that. So there you go. Now let's actually have an example of why this is actually bad. So this is example with task awaited demo exception. So let's say you are doing something here, and I just simply say starting the download, and let's say throw new exception. Okay. This is what void will do. If you actually do that, what will happen is let me do it in a different way. Await task.run, because I have to await it. I cannot do it anyway. So await, because if I say await working with tasks dot with demo exception, it says it cannot do that, but right now I'm forced to. So I'm gonna say await task.run, and I'm just gonna wrap it inside a task. Okay, so I wrap a thread around the thread. Okay, so let's say so. So a thread will spawn another thread, practically speaking. Now, if I run this, program finished. So the question is, what happened with this guy, right? So I'm right now throwing an exception. As you can see here, even Visual Studio grayed it out because it says this is unreachable code. This code will never execute because you are failing here. So here I'm going to say, haha, I failed you. Let's say like so, right? So that exception has been thrown with a message. Nothing happened. And this is because you are actually awaiting a void async function or async method. So how you would await this is why how you would actually fix that problem. To fix that problem, you need to let me put this, hang on, let me comment this. Example with task awaited, void awaited. Let me so like this, void awaited. And right now, the normal one, however, instead of returning a void, return a task. Okay? And right now, I don't even need to do that wrapper thing. I can say await task, working with tasks dot example. There you go. Example awaited demo exception. So right now this exception, this is void, this is normal task. One is gonna not do anything, the other one should. Right now, if I hit enter, or let me actually not confuse you, let me comment this so nobody says, hey, I'm doing something crazy. And right now the exception immediately came out. Okay, this is why it is recommended, not recommended, it is always advised that your async operations, your async methods should return a task, because if an exception has been thrown, we can catch it as a developer. But here, if you are having an async void, you cannot catch that exception anymore. Okay? It will just go like it will be swallowed and just gone. Nobody will know about it. So your program will fail and you will never know what happened. Okay? Let's see here. There is one more before we move to UI. Okay, so let me actually make this correct, just to be clear here. And this is normal functioning. So I will just simply remove the exception. So just to show you that this is right now how it should work. So I will comment this. And there we go. Run and run. And right now our program finished. Okay. So hopefully you have sense of how async await works. Right now, you are running multi-threaded application because of you returning a task, and you are actually creating an actual thread in here. You are awaiting a thread. In order for you to use await, you have to have an async word keyword up there. Okay. If you have async keyword and you don't have await in there, then your application just doesn't have, like, this method doesn't have anything, like doesn't have any meaning anymore. You see, it gives you even a warning. It says, because this call is not awaited, execution of the current method continues continues before the call is completed. Consider applying the await operator, because it will just simply like go through it and it's done, and will not wait for the result to finish. So await. There we go. Control S that. All right. Now let's actually go for. Now this is actually hopefully this is much clearer now. Let's actually do Windows. This is what you're gonna get in the exam, right? Right now, actually, it was just something like taking this thing out, taking the Windows Forms complications out, and just simply looking at the code. Right now, let's do Windows Forms, and it's gonna be multi-threading with UI. And yes, create this. I have to admit, I don't know why I have a feeling that Microsoft just broke the UI in .NET 6 for some reason or another, but hey, FRM I get like multiple crashes all the time. Yes, please. And I'm just gonna call this FRM multi-threading. And this is gonna be, this is the name of the control. I need the text. Where is the title? Title, there we go. Text, multi-threading demo. There we go. All right, so I'm gonna have a button here. And it's gonna be fairly simple. Give me a minute here, will you? I think I have like, or at least I did. I think I have. Oh, there we go. I have something here. Okay, so right here, I'm gonna have a button. So it's gonna be calling, like, has text like start work. So it just simply starts some work. I'm gonna have a rich text box right here. If I, come on, search rich text box. I'm just gonna push it right here and expand it until the end. Now, hopefully you heard about docking, so let me see RT result. I'm gonna call it that way because I would like to, print stuff out here. And I would like to access this text box, or rich text box rather. I'm gonna anchor it. So it's like anchoring means that, because if you run this, and obviously it will run the console application, hang on. I need to make this as a starting project. So set as a startup, run. And right now this is the, for real. Oh, fine. I mean, fine. Okay, start work. What the heck did those people do, I wonder? Really? It's like just broken. RT Results. Will you please be there? Okay. Now, obviously, this is actually not working. I would like to expand it a bit. So anchoring, what it does is you can think of it as like glue. So I'm gluing this corner and this corner here and here. So right now, if I expanding this, it will actually auto expand with the form, right? So this is actually good. If I didn't glue it, come on. If I didn't glue it from here or here, it will actually leave that corner, by the way. So if I do this, oh, of course they are because, sorry, they are actually described from the corner. The 0, 0 of any control is here, so that's why it will always there be, but fine. But there are some controls which will work that way. It will actually leave the corner. So that's why I'm going to just anchor it in all positions, just in case. So I'm just going to keep it there. And let's see. This is going to be a multi-threading demo. Now, if I do work, now there's one more thing I would like to do before I actually get started, because I have to, every time when I start, I have to drag the form here. If you are in a multi-monitor setup like I am, and you are debugging stuff and you would like to keep something in a certain monitor, start position equals to form start position manual. You have to say, I'm going to take a manual control where the form will actually show up. Again, this is not an exam stuff. This is like cool thing that you can pull off in case you're working with multiple monitors. So this dot location. And right now I can actually say at which coordinate will appear, but I would like to make it appear on a certain screen. Now screen dot all screens. Right now I don't know which screen it is. I'm gonna have to test stuff. Working area dot location. And right now I have to say which screen. So you have to bear with me until I experiment. Which one is this screen? So nope, this is somewhere else completely. Nope, this is completely somewhere else. 3, oh, come on. 4? Oh, it's 0 based. Oh, there we go. So it's actually running from 0. Okay. I have actually, because I have 4 monitors attached, so I have like, I thought it goes from 1 to 4. But apparently it goes from 0 to 3. So, okay, good. So right now, whenever I run this thing, it will just appear right here, which is good. Now, let's actually do something interesting here. So RT results dot text equals to starting downloads. And right now I'm going to do the same thing, right? Like downloading a huge resource. But for now, for fun, block UI thread example. And here I can say thread.sleep. And I can give it like 5 seconds. Okay. So the moment I press that button, right now I can actually do something here. The moment I press that button, I cannot do anything, right? And if I don't respond if this application didn't respond within 7 seconds, I think Windows will immediately say that this application is not responsive. Okay. So this is an interesting bit. So right now, as you could see that I could actually block the UI. Now you told me, now if you remember, I talked to you about the thread apartment, right? If you look at the, I can actually write it here. Current thread dot apartment state. This is very important. Dot to string. Yeah, dot to string. What? Deprecated. Oh. Get apartment state. like so. Okay. And right now, if I run this, after it dies for 5 seconds, it becomes STA. If you are working with Windows Forms, and I think WPF as well, STA is called a single threaded department. Microsoft has something which is called COM. It's written like this. And it's called Component Object Model. It's a pattern, or rather a guideline, for how several components can be actually talking to each other within a system. Okay? And for example, a button is a COM. A form can be a COM as well. Now, a single-threaded department, a COM in Microsoft Windows, and it's actually COM is something that is, it's actually, yeah, I mean, it's again, you can think of it as a pattern. In Windows, any COM object can be accessed only by the main thread or by single. It's actually a single-threaded thing. You are not allowed to access something from. You cannot make a thread from outside accessing the COM itself, right? So if a COM lives in a thread, it will be on that thread, and nobody is allowed to touch it from the outside. You can do that, but you have to ask for it in a certain way, which I'm going to show you, which for some reason people failed this in the exam. For some reason, I don't know why, even though the code is super simple. But I will show you what I mean by that. Now, why it is called STA, right? Why it's a single-threaded department? If you look at program.cs, you see this? This is STA thread. Now, by default, this is how Windows functions and Windows Forms. If you have a program that has multi-threaded department, you're going to mark it as MTA thread. But you will not do that. I haven't seen somebody does that, so you will actually leave everything as is. And because Windows by default uses COM, at least the native Windows, also the WPF, I think, we use all the time STA, or single-threaded department. And it is all, again, related to how COM works in Windows. And let's see how this actually functions. So right now, I showed you how to block a thread and showed you the STA bit, like the thread department bit. Okay, so here is an illegal way, and you will see in a minute. So if I actually mark this as async, here's an illegal way of doing things. Await class.run, and I will run this. Like so. Okay, now let me grab working with tasks. I'll grab this. Close that. I don't need you anymore. I don't need you anymore. Now let's see. So I don't need the console, to be honest, right now. I don't need any of that stuff. And I don't, again, I don't need the console. However, I need the downloaded data. So I can say, and again, it's going to be a blocking code because I'm not awaiting the task as it should be. But I can say rt result.text equals to downloaded data.result. I mean, you shouldn't do that like this .result, but anyway, it should be something like, I mean, because of this is, this can be actually set as, I could have actually put this like so, okay? Like so. And you don't need to actually say a task, await task from, because this is already an async function. But I'm just going to keep it here for simplicity so you don't confuse yourself too much. This could have been awaited, actually. Okay. But of course, await will not work because I have to say here it's async. Okay, and right now you don't need result here anymore because right now it should work. But anyway, yeah, this is it. Actually, this is it. This is how I would do it. Right now I'm running a thread, and I'm going to access a control from within that thread. Now we should be having a problem. So if I start this, immediately it says cross-thread operation not valid. Control RT result access from thread from other than the thread it was created on. This is the part where people quit the exam on this question. And it is really easy to fix. So in order to fix this, so this is like, let me put this here, illegal way of accessing a UI component. I'm going to copy that. The question boils down to how can I access this in a legal way? There are two ways of doing this. Way number one, rt result dot begin invoke, and then here, like so, and then here you say rt result dot text equals to that, and yeah, that's it. So this is legal version 1, legal way. There you go. So let me hit F5, start work. It downloaded the whole thing. And as you can see here, I got the whole output. Okay. Rich text box, by the way, allows you to bold text partially if you want to, by the way. I think I can. Nope, hang on. Can I do Control B? Nope, I can't. But anyway, it even highlights you links like so. So it's actually quite nice. You can get this interesting effects of WordPad, if you will. I don't know if you know about WordPad. It's built in. Is WordPad here? Oh, it still exists. So there you go. Here's WordPad for you guys. Similar to, I don't know if you remember this. Just it's installed by default on Windows since Windows 95, I think, and even before that. Okay. Okay. So this is legal way of number 1. Let me show you legal way number 2. So number 2, let me comment this out. Now, legal way number 2 is a little bit more involved. What you do is something what you call thread synchronization. So you can say var current, you grab the current thread context. And as you can see here, I'm grabbing it while in the UI thread. I'm not grabbing it from the inside. It has to be from the outside. Context equal to synchronization. Come on. Synchronization context.current. So please give me the current synchronization. Give me the current thread I'm on, let's say, or give me the current context thread I'm on. Okay. And afterwards, it's actually easy. You could say from here, instead of this, you say current context.post. And there you go. Post is right. Hang on. The signature is a little bit different. It should take a delegate, like so. I just remembered now, and like so. And I think it also has one more parameter, which I said should send null. I forgot what was the second one. A state. Yep, it's a state. So I have to send it that way. Now, of course, it says it can be null because you might actually not be able to get it. So I'm just gonna put a question mark here so I don't get the warning anyway. And here is the, yeah, of course, semicolon. And here's the next way of doing it. So starting the download, as you can see here, it works. The fun part is, look at this, starting download, and my form is free. See? So it actually printed out the thing, and it didn't block my UI, which is important. Let me see here. Very important. Let me actually show you this as well. So this, like right now, you know how not to block the UI thread. Okay. Let me show you what is exactly the order. Like if you actually think of order of operations is going to be a little bit weird for you. So let me show you this. I'm going to debug.writeLine. I'm going to use the debugger right now, which is the output window here. I'm going to write here, this is step 1. Okay, so this is 1. And I'm going to even print out the thread ID, so you know exactly where we are. So here, I should get the main thread ID, like the current thread, the current UI thread. So thread.currentThread.manage thread ID. Okay, let me copy this. And right now, I'm going to be step 2, right? I'm just going to happen to be here. 3, after maybe here. Then maybe 4. So hang on, let me actually put this correctly. So this is 3, this is 4. Before the post, I can actually, hang on, push it immediately here. So just to show you where things are, because you need to know. This is 5 right now. And this is 6. Okay. So 1, 2, 3, 4, 5, 6. Let's see the order. Like, let's see the order of code, not the order of execution. So 1, we are at the UI thread. Here, we are at the second thread because I said task.run. Right now, I initiated another thread. And this is running before the download. This is running after the download. Both of us here are on that thread. Here, it should be actually the main thread because I'm executing this on that context. Okay, so from within the second thread, I'm reaching out to the main thread. And right now here it should be in the second thread, right? Because I'm not in that post anymore. I'm outside here. And right now this is the main thread. Okay, so just to see here, so this is right now we will know who's the first thread, who's like the second thread, right? So there you go. If I run this, and before I actually do that, I will actually comment this part so I don't replace. Oh, actually no, because hang on, the output is here. Let me clear this and let us do work. All right, perfect. So let's see. So 1 is thread ID 1, and 2 is thread ID 3. Okay. Okay, this is fun. Wait, who is actually so 1 is thread ID 1, which is actually the UI thread. 2 is thread ID 3, which should be actually this thread. Right now, 3 becomes thread ID 6, which is here. 5 is actually thread ID 6. Probably, I don't know, did it change in between? I don't know. Probably it's the thread pool or something. But if you look at 4 and 6, is actually still thread ID 1, which is the UI thread, right? So here, you have reached from within this thread to the UI thread, of course, in a legal manner. Now, why this is actually thread ID 6, I have no idea. Probably it's how the thread pool is being managed or something like that by the task itself. So I'm not going to argue there, to be honest. Probably this actually has spawned another thread because this returns the task. So probably this actually has, like immediately spawned another thread or something. But hey, it is what it is. Now you know how the order was flowing here. All right, so now this is actually done. Let's see, we have like 15 minutes. Actually, there is one thing I would like to show you. This is an exam question. This actually appears on exams a lot, and nobody solves it for some reason. So let me show you to you right away, and Dennis, of course, will be showing this exam question, where you can actually print. You add to the database and you print stuff in steps. So var current. Oh, come on, let me actually copy this and paste that right here. And let's see, await task.run. All right, here I can say for.I equals to 10, and then it asks you to add something to a database, and then show, but do it like every 500 milliseconds or something like that, or 300 milliseconds or 1 second. It depends. And here you write custom stuff. So he tells you to write custom code. So yeah, it's another story, but I mean, it's easy that you can put here an I or something like that. So you can say from a text box, you can grab the input. I mean, it's easy, but I'm gonna leave it for you to have fun with this. Thread.sleep. And then I'm gonna make this sleep for 400 milliseconds. So you're gonna print out context, current context. Come on, for post. And right here, I'm gonna have a delegate. I mean, I could actually do immediately rt result dot begin invoke just to make it easier for you guys. I mean, I could use the current context. You already have seen the example for that, so I'm not gonna use it here, just to make the code shorter. And I'm gonna be like something like this. Right here, I'm gonna say rt results.text is gonna equal to or plus equals line number I, whatever. There we go. Probably to add the 10% here and semicolon. Okay. Now, obviously, you could be here adding stuff to DB, doing whatever operation you do, etc. But you have to do it like in an asynchronous way. So we put an async on a button, and then we do running, and then we say, okay, just sleep 400 milliseconds and do the rest, which is okay. Now, if I run this, you see it just prints it like one by one until it finishes and then it exits. Okay, it's done. As you can see here, it's like super simple. There's nothing fancy about this. But yeah, people studying exams, apparently they don't study the subject. So probably when they see this, they just simply like get stumped, even though it is like maybe 5 lines of code. I have like 10 minutes left. Let me show you something that you see in production. So far, you have seen asynchronous programming, which is totally fine. But what happens when you are looking at a shared resource? What happens if you have two threads trying to accessing one thing? You should be like, you probably have studied this in operating systems already. But this is a common programming problem that you will encounter once you do multi-threaded code. And how you synchronize multiple threads and stuff like that. There are many ways of doing this. Mutual exclusion, locking, semaphores. There's one more. Something about signals, managed signals. Oh man, I forgot right now. It starts with an M. A monitor, exactly, a monitor. I think this is it. I mean, there are many ways of doing things, but I just mentioned like the ones which I remember right now. Hopefully I didn't forget any. But let me show you the problem. So let's say you have an int I equals to 0. I consider it just a small bonus here. And I'm going to have a private, how about this? I'm going to add a button. Accessing shared resource. There we go. V10, accessing shared resource. Because this is like kind of unrelated to this, I'm just gonna put it right there. So let's say you would like to have var, I'm gonna use context right now. Var current context equals to synchronization context current. Good. Now I'm gonna have a new thread. And what it will do, it will increment I. I'm going to write it all in single line. And then current context dot send. There's a post, there's a send. And I'm going to put this synchronously because post is asynchronous. Send is a synchronous operation. So it is similar to post. You're going to give it a delegate. And right now I'm going to have here rt result dot text plus equals, and then I'm going to have here, let's say, first thread I \n, right? So just simply like have that. I'll put here a null. Let's start. You are not here, I think. Or probably are there, probably are there semicolon here. And this has to have a semicolon here. Okay. Writing all in one line is a super bad idea, but fine. You will live with that. Okay. And this is second thread. So what I'm doing here, now, if you remember from the beginning of the class what I said that once you go with threads like these, what will happen is that your program will execute all of them in one go, right? So these two guys will execute right away in parallel, right? Or multi-threaded, right? So both of them will run concurrently. So what is the result out of this, right? That's a good question. And let me actually even put the integer outside because I would like to press this a couple of times. So private int equals to 0. Int I equals to 0. Okay, so let's run this. Now, if I press this, so what happens here is this guy has incremented, this guy has incremented, but became 2, right? 4, 6, 8, 10, 12. Like you see, it's kind of weird right now, isn't it? But what you were expecting is thread 1 is incrementing this guy, then thread 2 is incrementing this guy. But apparently each one of them is overriding the other, right? But what you would like to do is, once thread 1 is accessing I, you would say, okay, nobody accesses I until I'm done. And then once I'm done, let anybody else can have access to I and then do something, right? This is similar what operating systems do with a processor, is that a process holds the CPU, does the memory and stuff like that. Once I'm done using my resource, leave it and allow somebody else to use it. Now, there are multiple patterns to solve this. One of them, and this is the simplest, is the locker. So if I actually, let me duplicate this. I'm just going to comment this because it's going to be a little bit different. So this is accessing shared resource problem. This is solution 1, I think. A probable solution 1. I'm going to create something which is called an object, and it's literally object. I'm going to call this locker equals to new object. Okay. And right here is, you see, it's even like, it knows this. So the easiest way is to surround this by a lock. Now, I'm going to actually, private void do actual, I need to separate this because it doesn't work that way. I mean, as you might have imagined. So what is the actual work I'm trying to do? I'm trying to do this. Sorry, I'm trying to do this and this, right? This is the actual work. So I'm going to grab these two guys, put them here. So first thing first, I++, second. Now, obviously, we don't have a current context because it's not public, so I'm just going to make it, well, public. I'm going to call this like so. Hopefully, I didn't make a mistake, which is good. So right now, this is not it. This right now, it can take a delegate, which is this guy, like so. And right now, I have two threads doing exactly the same thing. By the way, this is identical. Actually, I could do this like so. And let's see. What is your problem? So you are missing this and you are missing this. Okay, good. So this is identical. I just simply separated this into its own function because this has to be locked right here. So as long as this resource is busy, do not touch it. Once it's done, you can actually do the thing. Okay? So this is the solution 1. Now let's see. What did I do wrong now? Sorry. There we go. Any complaints so far? Probably I'm missing the null bit here. Okay, perfect. Now let's actually run this. So this is the solution. So if I had actually accessing shared resource, hello? I mean, it's running. What am I missing? Let's see, can I debug log this? Debug write line. Let me debug write line this. Maybe I'm missing something. So I'm printing this out in the output. Just give me a minute here. Oh, I don't know what I'm missing, to be honest. I think. Well, it says first thread and the first thread. Oh yeah, of course, there are no first threads and second threads, just only a thread. So let's see. So 1 and 2, 3 and 4, 5, 6, 7, 8, 9, 10, 11, 12. So it's actually working. I don't know why. I don't know why it's not working here though. This is super weird. Could it be? Could it be? I mean, that would be super weird, but could it be? But I mean, this cannot be it, but you may never know. Oh, And this, now it's working. Probably I have to pull it out from the button while I'm in the button, actually, in the UI thread. So right now, yeah, there you go, it's working. Apparently this, when I do it here, it's not in the UI thread, or I don't know what is it, but okay. So there you go, it actually works. So right now I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You see, it's like right now things is incrementing. Actually, there's like it should be I equals to rather than a thread, because right now it's a multi-threaded thing. Now it's actually 5. I would have loved to show you. There we go. It just keeps incrementing correctly. I would have loved to show you, I think, I want to show you actually monitor, but apparently, like, well, let me think of this. I mean, lock is simple enough. Monitor is actually similar to lock, except it has more methods, but yeah, maybe I will show it next time, I think. All right, stop recording here.